Hello, my dear students. I welcome you to this lecture ESM 291 Map Analysis. We are now on lesson number 2. Please stay tuned. Come along as we now dig deeper into the course. I am Joseph Omada, your facilitator. Um, Thank you for keeping on and staying with us. Map analysis. To understand the map, please let us take the following steps. Get the map. Let's get the title of the map so that we know where the map is coming from. Let us get all the symbols in the map or on the map and try to understand them, and then know when the map was produced. Timing is very important. As you know, many things have changed today. What was done very well 10 years ago cannot be repeated by the same process and will have the same kind of result easily now. So let's get um, the what, the where, and the when of a map before we think of the interpretation. Number 2, critically look at the symbols. Once we know the symbols, and we know the symbols very well, we can go ahead to interpret. Okay, number 3, what are the scales? Scales of the map. We must know them, and of course the orientation of the map is important. So for the map analyst, he or she will be involved in classification, delineation, enumeration, and classification involves assigning objects, features, or areas to classes based on certain criteria. There are 3 levels of confidence or precision when doing classification. First, detection, which is the determination of the presence or absence of a feature on a map or group of features on a map. Then recognition involves assigning a feature to a general class, and identification, which means we have enough details about the identity of a feature and can therefore place it properly where it belongs. Delineation. This refers to outlining or placing boundaries around regions or areal units observed on the map. A typical example is a delineation of separate classes of land use or vegetation or lithology. You want to say, no, these rocks are igneous, the other ones are metamorphic or sedimentary. Enumeration. This refers to listing or counting discrete items visible on a map. We need a large-scale map to do this, and we can be able to look and pick number of houses, boreholes, bus stops, petrol stations in the area. Measurement. Quantitative measurement of certain variables such as length, height, volume, perimeter, and area can be done on a map. On a topographic map, we can measure and calculate the distance between 2 places, the height of a peak of a hill or mountain, or the area of a lake. We use contours. Contours are lines of equal height on a map. So, and the distance between one contour and the other is a known height, such that we can count the height and get exactly the distance, either from one place to the other or above another. Geographical data They are very important, just like geological data are also important when we want to understand maps. But critical is the symbols that are used on the map. Okay, what are the symbols? Lithological symbols, geometric or geographical symbols, such as point, line, or area. We understand this, then we can go to begin interpretation. Points on a map represent just a single dot. But that dot must have XY coordinates. In other words, there must be longitude and latitude. And small as they are, very important in describing an area. Arcs or lines are other sets of points that have the look of a straight line or curved, depending upon the feature it is describing. For example, a road will normally curve, rivers will normally curve, but because of the height from where the photograph was taken, you will see a river or the road as just a small line. So we use lines to describe certain things. Now, polygons and areas, when we have closed features and the boundaries enclose a homogeneous area. For example, the tone. You look at photograph or a map before you, you will see that certain areas are homogeneous, others are heterogeneous. You draw a line, and if your line closes, then it becomes an area. So in an area, the lines must close. And in other words, your XY coordinates will be, for a long time. It has X, it has Y, it has even Z. So that is why areas are different from lines. They are used to represent features that have area like lakes and so on. Sources of data for mapping, primary and secondary. A researcher that goes out to collect original data by himself or herself is collecting primary data. But if he is using data collected by somebody else and already used, even if it wasn't used by that person deserves acknowledgement. And that is secondary data. Field notes are good examples of primary data. If we have satellite images, area photographs, GPS, global positioning system data, we can use them as primary data in terms of the interpretation that we derive therefrom. Map symbols. Symbols are very similar to what we have talked about earlier. There could be point symbols, line, and symbols. So, but in addition to point, line, and area symbols, we also have textural symbols. We can say SCH to mean school, MKT to mean market. You can add your own textural symbols onto the map, provided that what you mean is written there under the key. Now let me just make this quick distinction between key and legend. Legend is saying that you are presenting features in a chronological order, such that the oldest of the features, the oldest of the lithologies are the base. The youngest of the features, the youngest of the lithologies are on top. Okay? You don't say you have a river before you have a fracture. Fracture must exist, and then river water will flow such that it gives you a river. So these are some of the examples. So when you input, please put the meaning of your symbols. In closing, let's say it this way, that um, to interpret a map, please know what the map is about, know where it was taken from, know when it was also taken. Number two, get to know the scale. Number three, please input yours if you want as you try to do interpretation. Thank you for listening. I am Joseph Amada, your facilitator. Please join me next time. Bye for now. Pictures. One particular